Hello everyone, today let's solve the problem number 73, set matrix zeros, right? So let's see what the question states here. So we have been given an m into an integer matrix, see here, integer matrix, right? If an element is 0, then we have to set its entire row and column to zeros. If one element is 0, see here, suppose this is 0, so then we have to set its entire row as well as the column to 0. This one, let me show this one with a color so that you'll be understanding clearly. So this entire row and this entire column has to be 0, right? So that's what they have shown. See here, 0 0 0 and 0 0 0. So we have 0 here, entire row and entire column has to be, we have to set that one to the 0. That's what we need to do. Same goes with the example 2 as well. See here, we have 0 here, we have 0 here. So we have 0 here, obviously this also becomes 0, but we have to note this one, this is also 0, so this column has to be 0 as well, right? So this column has to be 0 and this entire row becomes 0 as well, and don't forget we have 0 here as well, so this also becomes 0. See here, 0 0 0 0, 4 zeros, the first column entirely 0 0 0, the last column is 0 0 0 as well. Same thing, right? So they have given us wonderful examples just for the sake of understanding. Now let's consider the same first example here. Just give me a second here, 1 second. Yep, just give me a second here. So yeah, let's consider first example, right? So for the approach, basically let's discuss the approach. One thing is we will be going with a geometry approach, math or simple math or geometric approach, basically. Just remember this one, man, right? So first thing here would be, so we have to think of the matrix as the 2D coordinate plane, right? So just think of the matrix as the 2D coordinate plane where 0 at row comma column projects like a geometric progression, right? So I'm speaking of the zeros along the horizontal axis, nothing but the row. We have considered R, right, for the row, and the vertical axis nothing but the column C. So we will be making use of the first row as the horizontal axis flags and the first column as the vertical axis flags to accumulate the particular projections, right? So this basically gives an in place big of one extra space method. Let's try to apply the same thing for the example one. You will understand this one clearly rather than I saying that one with this one theoretical part. Let's try to understand the same thing whatever I have said. Let's try to implement for the example one, right? So we have to scan the first row. First we are considering this example. Let's scan the first row and first column to record whether they originally contain 0 or not, right? So we have to store two booleans in this case because we have to scan the first row and the first column to record whether they are originally contain a 0 or not. We'll be considering two we'll be storing two booleans. Then we have to scan the rest of the grid for every 0 at I comma j, meaning we have to set the matrix of ij to the 0, mark column I, and matrix of ij to the 0 and mark row j, right? For example, see here, 0 at 1 comma 1 we set matrix of 1 0 equals 0 and matrix of 0 1 equals 0. Basically what happens here, this one becomes this one becomes 1 0 1. This is fine. This second row becomes 0 0 1 and the third row becomes here 1 1 and 1. This is fine. So 0 at 1 comma 1 basically, right? 0 at 1 comma 1 in the sense this one, right? So this is 0 0 0 1 0 2. This is 1 0 1 1 1 2. Cell number I'm saying, right? So here this one is nothing but 2 comma 0 2 comma 1 and 2 comma 2, right? So this is fine, I believe. So in the second pass what we'll do, excluding the first row and the column, we will be setting the matrix of ij to the 0 if matrix of I0 is equivalent to the 0 or matrix of 0j is equivalent to the 0. After this pass, the interior becomes basically this one, 1 0 1. This is fine, 1 0 1, then followed by 0 0 0. This one is nothing but 0 0 0, 0 0 0. This is fine. Then finally the final row becomes 1 0 1, 1 0 1. This is fine. Yep. So finally what we'll be doing, finally the 0 the first row, finally 0 the first row and or the first column if the initial booleans showed they had original zeros. In this particular example, they did not. So final result would be, so this one itself 101, this one 000 followed by 101, this one itself, right? So final result will be this one. The output that we got here is 101, 000, and this one, what do we call, 101 basically, which is equivalent to the output that they have given for the example 1 within the question. So our approach works absolutely correct in this case, right? So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities, right? So before discussing this one, complexities, let me tell you one thing. Whatever the approach that we used, basically at the end it uses the matrix, this one access as flags, basically access in the sense access plural, right? So this uses the matrix access as flags, basically geometry of rows or columns I'm speaking of, and only true extra two extra booleans we are making use of, right? So as I've said that one earlier, during the approach we'll be making use of only 2 extra booleans. So this is it for the approach. Let's come to the complexities part. So what will be the time complexity here? So the overall time complexity would lead to big O of m into n, right? So overall time complexity would lead to big O of m into n, because we'll be scanning the matrix constant number of full passes, right? So we'll scan first row or the column plus mark pass, plus will go with the apply pass, plus also option first row or column, this one zeroing, right? So overall time complexity would quite obviously it will lead to big of m into n, right? So this is fine, I believe it's easy. Space complexity would lead to big of 1, because we'll be making use of only 2 boolean variables, as I've said. So overall space complexity would lead to big of 1, right? So just give me a second here. The time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of 1 respectively, right? So now as we are completely familiar with the approach and the complexities, let's start writing the code. So the first part here would be this one. So let's go with the m and n, nothing but the number of rows and number of columns, right? So let's go with the rows and columns here. First rows. So let me copy this matrix basically. So I'll just go with matrix dot length. Also for the columns I'll just go with m equals matrix of 0. So this is for the column, right? Matrix of 0 dot length. This is fine. So the next part is we have to record whether the first row or the first column originally contain any 0, meaning we need these because we will reuse the first row or the column as marker storage accordingly with the approach. So let's go with the 2 boolean values basically. So variables basically. So this one will be boolean first row, this one 0. Let's set this one to the false, and boolean, let's go with the first column 0. So let's go with, or let's set this one to the false. This is fine, man. Let's check the first row for a 0. So this is fine. This one will be for int j equals 0, j less than n, j plus plus. So within the for loop what we'll be doing, let's go with a simple if condition. So this one will be if matrix of 0 j, so this is equal to 0, then meaning if any element in the first row is 0, then we have to remember to 0 the entire first row later, right? So nothing but here, so let me set the first row 0 to boolean value true here. Also let me give break here because we don't or no need to continue here, right? Scanning the first row, right? So let me come out of this one entirely. Now after checking the first row for the 0, we have to check the first column for the 0 as well, right? So I can copy paste the same thing and make the necessary changes. Let me do this one itself, right? So this is fine. So instead of j, I'll just go with I here, int I equals 0, I less than, so we are going with a column, I'll just go with m, so this one will be I plus plus. If matrix of instead of 0j, so this one will be I 0. If this is equivalent to the 0, again instead of the first row 0, so we will be going with the first column 0 basically, right? So this one we are setting this one to the true, and we have to just break, right? So this is for the first column, when first column is 0. Next what we will do, we have to use the first row and the first column as markers now. For any element matrix ij equals 0 excluding the first row and the first column, we have to set the matrix I0 to the 0, meaning we have to mark this particular row and matrix 0j equals 0, and basically we have to mark this particular row and mark this column, right? So I have to write that one in the form of code. First let's do one thing, let's start from row 1 to avoid the overwriting this one first row. The same thing let's the column as well. Let's start from row 1 and column 1 to avoid overwriting first row and first column respectively, right? So I'll just go with the two iterations here. So this one will be for int I equals 1, I less than m, so this one will be I plus plus. Next for loop, let me go with int j equals 1, j less than n, j plus plus. So this is also fine. So within the for loop, let's go with a simple if condition. So this one will be matrix of I j. So if this is equivalent to 0, this one has to be matrix of I, this one 0. Let me assign this one to the 0. Also matrix of 0, this one j, this one is equivalent to the 0, right? So we have to mark the entire row, the I should be zeroed here, and also we are marking the entire column that j should be zeroed, the line number 26 and 27 I'm speaking of, right? So let me come out of this one entirely. Now we are left with this one. Now we have to set the matrix of ij equals 0 for the interior cells based on the markers in the first row or column, right? So again let me go with for loop here, and I equals 1, I less than m, so this one will be I plus plus. So next one more for loop here, this one int j equals 1, next this one will be j less than n, so this one will be j plus plus. So within the for loop what I'll do, let's write the simple if condition, meaning if neither the row marker or the column marker is 0, then this particular cell becomes 0 as well. So I can just write it in this way, if matrix of this one I 0, if it is equivalent to the value 0, or so this one matrix of 0, so this one is nothing but j, so if it is equivalent to the 0, then what we have to do within the if condition, so I'll just set the matrix of this one I and j. So this one, let me set this one to the value 0. This is fine. Let me come out of this one entirely. Now finally what we need to do, if the first row originally had a 0, then we have to 0 the whole first row, meaning, so I can just write it on this way, if first sorry, if first this one row 0, then let me go with a for loop here. This one has to be int j equals 0, j less than n, j plus plus. So this is fine. So within the for loop, so we have to set this one, right? We have to 0 the whole first row, right? So this one will be matrix of 0 whole first row. So this one will be j. Let's set this one to the 0. So let me come out of this one entirely. So if the first column originally had a 0, then we have to 0 the whole first column, right? So same thing, let me copy this entire thing here. So this one, let me give here, instead of the first row, let me make this one to the first column 0, right? So this one will be int I equals 0, I less than m basically, and this one is I plus plus. We have to increment the I. So we are iterating all the rows on the column 0 basically. Finally we have to set them to the 0. Here instead of the 0j, this will be I and 0, right? So this one we are setting this one to the 0 basically, right? So this is fine, man. This is fine. Yeah, we have successfully written the code. Right, so we are done with the coding part. So let me hit the run button. I hope this works, man. Let's see. We are having the compile error. Cannot find the symbol column first zero. So yeah, I have given here column entirely. So everywhere I have made use of COL basically. So let me set this one to the call zero. Array out of bounds. Let's check what we have done wrong. Just give me a second here. So what mistake I have done here is this one has to be I, we are considering the row, and J we are considering for the columns, right? So I have given reverse here. This one again, this one has to be N and this one has to be M. Let's try running this one again. Let's see whether this works or not. Still we have so here also we need to change, right? So I forgot this one. So here also the line number 4, this one J less than M and this one I less than N. Basically let me run this one. Let's run the code. Yeah, now this is showing accepted. Basically that was the main problem. So everywhere for the I it has to be I less than N. So we are going with the rows, right? So here for this one J we are considering for the columns basically. So that one I did reverse, so we were getting the error. So now let me hit the submit button. I hope this works for all the test cases, man. Let's see. Only 5 test cases are getting passed. So let's see what's wrong here again. So here, yeah, in the first 2 loops also we have to change this one, and everywhere I had to change basically. So J is related to the column, so this one M we have to go with, and I is related to the rows, so we have to give N here. So let me run this one again. This time it has to work for all the test cases. Let's see. Let me hit the submit button, man. Yeah, now this is showing accepted, means whatever the code that we have written works absolutely correct. So this was the main confusion basically, right? So N and M basically. So N we are considering for the rows and M we are considered for the columns. So I got confused here basically. This is fine, man. Now we are done with the coding part basically. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.